And welcome back, students. We are now going to continue to talk about overloading. This time we talk about the pitfalls of overloading. So last time we talked about the rules, now the pitfalls. So, pitfalls. All right, the first one is overloading and automatic type conversion. So automatic type conversion of arguments such as int to double when the parameter is double, and overloading can sometimes interact in kind of unfortunate ways. So to start off, let's consider the following method be added to our day 6 try class. We're not actually going to add, we're just going to think about it. Public void increase double factor, and we're going to say year is equal to int times year plus factor times year. And notice this int is in parentheses, which means it's going to do a typecasting. If we add that method to the class date 6 try, then the following will present no issues, where date is an object of type date 6 try that's been set to some date. Date dot increase 2. The int value 2 is a typecast to the double 2.0, and the value of date.year is changed as follows. Date.year equals int date.year plus 2.0 times date.year. Because year is a private variable in the class date 6 try, you cannot write this in a program that uses the class date 6 try, but the meaning is pretty clear as to why that is. I mean, obviously, if you remember our whole spiel about private variables, it makes sense. Now, suppose we also add the following definition to our class day 6 try. So we haven't overloaded it yet, but now we're about to. So now we have another public void increase, but now it passes in term. And that's just year equals year plus term. So now we have two increase methods. Now, so far, this is valid overloading because the two methods named increase take parameters of different types. If we recall, our first one took a double, whereas this one is taking an int. Now, with both these methods named increase added to the class, the following now behaves a little differently. So date.increase2 is going to behave slightly different. So we are actually map out that it's going to be different. This is why, because if Java finds an exact match of types, it uses the method definition with an exact match before it tries to do any conversion. So our method is now equivalent to date.year equals date.year plus 2. Remember before it was 2.0 with the int conversion and stuff like that, but now it doesn't need to because it's using the int method. However, if we use the argument of 2.0 for date increase and instead use 2, counting on it to do an automatic typecast, then this is not what you want. It's best to avoid overloading where there is a potential for interacting dangerously with automatic type conversion. In some cases of overloading, a single method invocation can be resolved in two different ways, depending on how overloading and type conversion interact. Such ambiguous method invocations, though, are not allowed in Java and will produce an error message. So this is one thing you obviously want to avoid. That's the whole purpose of a pitfall. You want to avoid these things. So let's look at this example where we overload a method named doSomething by giving two definitions that have the following method headings. Public class sample class, public void doSomething double n1 int n2, public void doSomething int n1 double n2. So you'll notice that the methods are the same, but they have the parameters switched around. Now, such overloading technically is legal. Right? Syntactically, there's nothing wrong with it. But there is an issue present. So suppose we make an object called sample object, and that object belongs to our type sample class. An invocation such as the following will produce an error message because Java cannot decide which overloaded method that it's supposed to use from doSomething. So if I have sample object.doSomething 5, 10, it's going to be kind of ambiguous to Java. Java cannot determine whether to convert the first value to a double or the second to an int, because if you remember in our one method we have an int and then a double, or we have a double and then an int. So it doesn't know which way it wants to go. In this situation, the compiler is simply just instead going to issue a message that the method invocation is ambiguous because it doesn't know which one it wants to do. It's like, well, I don't know what to do, so I'm just going to quit. I'm just going to give up. So that's why we have to kind of really be careful here when we start using overloading. All right, so here's one possible solution. If you use the code below, the invocations will be permitted. Sample object that do something 5.010, sample object that do something 5, 10.0. Now you can see that differentiates it because we have a double followed by an int, and then int followed by double, because ints cannot have decimals. However, obviously you can see this looks like this should take some remembering efforts. Okay, which one needs to be this, which one needs to be that? And that's why situations such as this are pretty confusing. I mean, if you had to try and remember which one had to be, I mean, this is just a really easy example, but if you had to try to remember what value goes where, and if you had some that had to be doubles, some that had to be ints, it can get confusing. So they're best to be avoided. All right, here's our next pitfall. You cannot overload based upon the type returned. So please note, the signature of a method only lists the method name and the types of the parameters, but it does not include the type returned. So it doesn't say if it returns an int, it doesn't say if it returns a boolean, it doesn't tell us. When you overload a method name, only two methods must have different signatures. Any two methods can have different signatures. The type, though, returned, has nothing, though, to do with the signature of the method. So, for example, this one, let's just say, has first method number 1 has parameters int, int, int. Method number 2 has parameters int, double int. Technically, those are different signatures. But let's just say method 1 returns type int. Method 2 returns type string. They have nothing to do with necessarily this. And that's because, if you look at that example I just gave, the second one returns a string. So therefore, what does it have to do with int or double? Right? Yes, they can be converted over, but it has nothing to do with those parameters. All right, continuing this pitfall, let's look at an example. So a class could not have two method definitions with the following headings. So public class, sample class 2, public int, compute something, int n, public double, compute something, int n. Java cannot allow this overloading. In fact, it's going to give you a big hissy fit about it. And let's explore part of the reason why. Suppose an object is an object of the class sample class 2. In the following assignment, Java would not be able to decide which of the following two methods to use. So double answer equals an object dot compute something 10. Either a value of type int or type double can legally be assigned to the variable answer. Because of this, Java simply states that it is illegal to have both method headings in the same class. And that's it, folks. That concludes our notes on overloading. So until next time.